Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillah ar-Rahman ar-Rahim. This video is presented by Mohammed ABDULALEM from Group 14, providing an explanation for Group Assignment 2, ALU Design. Here we can see the full ladder design using basic gates. We have three inputs, A and B, the numbers that will be added, and the carry in. In the output, we have the sum and the carry out. Now let's generate the waveform, but before that, we compile the design. Let's add a new file, waveform. We insert the input and the output. I will generate random values for each, for A and B. Now let's run the waveform. We need to save it. As we can see here, in the first we have 1 and 1. So the output will be, S will be 0 and the C out will be toggled. And as we can see here, A is 0 and B is 1. So 0 plus 1 will equal 1. A is 1, we can see here, A is 1 and B is 0, and the output is 1. Here's the 4-bit full adder. It consists of 4 1-bit adders. It's just we added the XOR gates for the bus line, which is the input, 4-bit input, and we have A 4-bit input and C, I, and at output we have the carry out and the sum as 4-bit number. The XOR gates for B just to apply the 2's complement in the case of subtraction operation. Now let's go to the simulation. As we can see here, we generated random numbers. And first we have 7, here is 7, and we have here 4. So if Ci is 1, this indicates a subtraction operation. So 7 minus 4 will equals 3, as we can see here. And 0 for I indicates addition. So 7 plus 4 will equal 11. For the others, they prove that the circuit is working well. Here's the 4-to-1 multiplexer. We can see here the inputs are here, and the output is here. And this for selection. Let's go to the simulation. As you can see here, we have the inputs. These are the inputs, and the selection is here, as indicated in this value. And the Y is here. I put some values to select to approve the functionality of the mux. We have here 1, 1, which is, we'll select this one. So it's selected because the others are low. And then 1, which is I1, it's also high. This one is 3, 3, yes. So this indicates the functionality of the multiplexer. This is 4-bit 4-to-1 multiplexer. We use the multiplexer we created. We have 4-bit inputs. Now let's go to the simulation. As we can see here, the selection line is here. We selected 0, 1, 2, 3. As we can see here, the simulation is proving that our multiplexer is working well. The output is the same, and here we can see the output is the same. This is the 2-to-1 multiplexer for operation selection, as we can see here. Now let's go to the simulation. And we can see here the simulation is proving that our multiplexer is working fine. We have the register here, consists of 4 D flip-flops. In the input we have D, the bus 3 to 0, and clock reset, and the output we have Q. As you can see here, the inputs of the D flip-flop 0, 1, 1 is directly mapped to the Q after the rising edge clock. And after compiling all these designs together, we will get this design, which is the ALU design. This is the 4-bit multiplexer. Disposed, one for A and one for B. This is the 2-to-1 multiplexer for the selection operation. And this is the full adder, and this is the register. Now let's go to verify our design in the simulation. As we can see here, these are the values of A, and these are the values for B. A select is here, and B select is here. And this is the clock signal. Reset must be always high because it's active high, the register is active high. And the operation select. If it's 1, it will be addition. If it's 0, it will be subtraction. Let's go to the first number. We have addition operation. The select is 1, 1, which is this value, which is 3. And for A is this value, 4. So 4 plus 3 equals 7, which is correct. Now let's go to the subtraction operation. The B is 1, 1, which indicates -8 as 2's complement. And for A, we are 0, 0, which is 0. So 0 minus 8 will equals -8 in 2's complement. This was the explanation for verifying the ALU design for group assignment. I hope you enjoyed this explanation, and this is Mohammed ABDULALEM from Group 14, and I hope you have a good day.